Hello everyone. I wanted to take a look at the weekly task 2 question where we were told someone's taking 10 true or false questions. They're going to randomly guess on every question, so no skill involved. What's the probability of them getting a 75%? So the best way of looking at this is in a case-by-case basis, starting with how many total outcomes there are. So since this is probability, this is going to be a ratio of success over total outcomes. Think about basic probability, right? Like rolling a certain number on a die would be like 1 out of 6, right? So the number of successes over our total outcomes. So let's start with that total outcomes. If we're taking a 10 question true or false test, there are going to be 2 to the 10th power, or 1,024 different outcomes. In other words, for each question, one of 2 things can happen. I'm not going to go down the whole line here, but for each question, we have 2 options, right? For 10 total problems, 2 to the 10th power. Okay, so that's our denominator. Now for our cases, there are 3 ways of getting a 75. One would be getting 8 questions correct. That's actually going to be the most troubling one for us. Getting 9 questions correct. Or lastly, getting 10 questions correct. In other words, you can't get exactly a 75, but you have an option of getting an 80, getting a 90, getting a 100. It did say at least a 75. It could have said at least an 80, and that would have been the exact same problem. Just, I guess, to throw you off a little bit there from the start. So let's start with getting 10 correct. There is only one way to get all 10 questions correct. Okay, that one doesn't require much calculation or much thought, right? If I'm taking a 10 question test, there's only one way I can get everything correct. Now, getting 9 correct, also, you can kind of work your way through this without any formulas or anything like that. Think of it this way. Let's say like we'll put a few checks and like an X, right? Getting 9 questions correct, if you're having trouble with that part, like there's an example of me getting 9 correct and 1 wrong, I can think of this as just a matter of moving this X in different spots. That can happen 10 different times. So again, think of it like as an X, and that X can occur in the first slot all the way through the 10th slot. So we have 10 cases of getting 9 correct. Okay. Getting 8 correct is a little bit more challenging, and this is going to involve combinations. Getting 8 correct is a matter of figuring out how many ways there are to choose 8 check marks out of these 10, and also taking into consideration how many ways are there to put in 2 incorrect, like 2 X's into these 10 slots. So this one is a little bit harder to demonstrate. The answer is quite larger than the other 2. This is going to be what we call 10 choose 8. If you've ever seen that notation before, it's basically saying out of 10 items, how many ways can we choose 8 of them? Okay, the formula for this is going to be 10 factorial over 8 factorial times their difference. So in this case, 10 minus 8, I'm just going to say 2 factorial. Now with factorials, if you haven't seen this before, factorials, real quick, are, for example, 10 factorial, 10 times 9 times 8 times 7. I wouldn't go ahead and type that in just yet because you can do a lot of canceling here. For example, 10 factorial is 10, 9, and then 8 factorial, right? So that's going to cancel with the 8 factorial we have in the denominator. I didn't want to just list that all out, but 8 times 7 times 6. So that's going to cancel with the 8 factorial we already have. And 2 factorial is just 2 times 1, so pretty much just 2. We can reduce that. And all we're left with is 5 times 9. So 10 choose 8, which you can do on a calculator, is simply 45. On a TI-84, I believe it's the math button, and there's a probability section. It may say PRB. And I can show you guys that next week. So 10 choose 8, 45. So we have a grand total of 45, 10, and 1, 56 successes here. Okay, again, getting the 8 correct, it's a little difficult to illustrate or show you how that's happening with checks. I'm not going to show you all 45 cases, but again, combinations are a matter of basically saying, like, think about off on the side having 8 check marks and 2 X's here, right? Getting 8 correct. It's, hey, how many ways can I put these 8 check marks in here? And you also have to take into consideration, that's what the times 2 basically was. How many ways can I put these 2 X's? So that's only going to be 2, right? I could put them one way or flip-flop them the other way. That's what basically the 2 in the denominator is doing. And that gave us 45. We'll talk a little bit more about combinations perhaps in our next meeting as like a little mini lesson. All right, so let's put everything together here because we have some reducing as our final step. So we said it's a ratio of successes over total outcomes. So 56 over 1024. Obviously, these are both even. They have a few more things in common as well. I believe they have a GCF of 8. If you have a calculator, graphing calculator, you can enter these in. You could hit 56 over 1024. It will do the reducing for you. Otherwise, your simplified form would be 7 over 128. It does say as a common fraction, so we would want to reduce this. 7 over 128 for the correct answer here. I'm going to browse through some of the solutions that you guys did post. I think a lot of people threw out some variations on like the 1024 and maybe just a numerator that you didn't take into consideration in the different cases here. It's a little bit of a challenging problem. Combinations and problems like this are difficult for a middle school math team because the math is a little bit more Algebra 2 related. It's a little bit above our curriculums that we're currently in our math class. So we'll try to go over some topics like permutation, combinations, stars and bars, strategies that can be used for problems like this. All right, thank you guys for watching, and I'll see you next Tuesday.